talked about volume studies which are done for the what you call the statewide program. And then we looked at the grouping of the control locations, how we can group the adjustment factors from different locations together. Now, this was all for the control counts. The adjustment factors are calculated from the control counts, and then you try to group the locations for the control counts as well. Now let us talk about the coverage locations. Now remember, on the coverage locations, I don't have the full data, so I cannot calculate ADT directly. Okay, in all the previous examples, we calculated ADT and then the adjustment factors. So what if you don't have enough data to calculate ADT? So what can we do in that case? This is where you use the adjustment factors. Okay, so for example, you have only 1 day of data from any location. So obviously, average cannot be calculated for the whole year. So what you do is then you go and find which one is the control count for this location. Okay, which one is the control count which will is closest to this location of the same type. Remember, I told you that you cannot mix between different types of roads and different types of areas. You will look, okay, I have location A, which location, which control count location is closest and the same type as location A. And for that location, for that control location, you must have calculated the adjustment factors for the day of the week and for the month of the year. We have done that in previous example, both of them. So you take the adjustment factors. So let's say on your location for which you are trying to find out ADT, the count is taken on what is today, Monday, right? Monday, and the month is April. Okay, so I took a count on Monday, April. So I'll go to the control count and take the adjustment factor of Monday, April. Okay, and I multiply with the count of this particular location for which I'm trying to find out ADT. So after multiplying, you can get ADT, which is what is written on the slide over here. So V is the 24-hour count for the location, coverage location. DF means the adjustment factor for the day on which data was taken on coverage location. MF means the adjustment factor for the month in which the data was taken on the coverage location. Okay, so you have taken these two factors from the control and V24 from the coverage. You multiply them, you get ADT for the coverage now. Okay, so let's say this is this example. So for a control location, the factors are calculated, which you can see in the table, factor for each day and factor for each month. And for another location, okay, which is of the same type, I took only 1 day of data, which was Tuesday in July. Okay, so if I want ADT for this data of 1000 vehicles, I want to convert this into ADT. So I will I'll do this ADT 1000, the data which you have taken. Data is for Tuesday, so 1.1 to 1, the factor of Tuesday. Okay, adjustment factor of Tuesday. The data is taken in July. What is the adjustment factor of July? 0.913. Okay, so this is how you calculate ADT for the coverage location. You need adjustment factors, and this is why we were discussing adjustment factors in the previous lecture. This is why they are important. And keep in mind that control counts are few and the remaining are all coverage. Okay, so you will calculate control from few locations and then you will apply it to many locations. We talked about a ratio of 1:20, 1:30, and so on and so forth. So one adjustment factor could apply to 20-30 locations. Okay, this is another example, but in this example you will be calculating the VMT. You can see here VMT. Who can give me the full form of VMT? VMT means what? What do we mean by VMT? Yeah, anyone? This was discussed in the previous lecture. Vehicle miles traveled, yes. Okay, so we will multiply the volume with the length. Okay, so if you see here, the volume is given here 24 hours, and the length is also given. Okay, but if I multiply this volume with this length, then it gives me VMT for Wednesday in March. Okay, I need the VMT of the whole year. I need annual VMT. Annual VMT. Okay, so annual VMT will come from annual volume. Okay, so what is annual volume? The average of annual volume is ADT. Okay, so I have 6 locations. For each location, the length is given, the 24-hour count is given, and the day and the month for that count is given. And they are asking for annual VMT for each one of them. So these locations are near the control count of these adjustment factors. Okay, so all of them are, or these adjustment factors are can be applied to all these 6 locations. They are of the same type and in the same area. So how to calculate VMT? Annual VMT. Annual VMT means the VMT for 365 days of the year. So first of all, I will calculate traffic. So I'm talking about location 1, let's say. Okay, first of all, I will calculate ADT, meaning average traffic on any day of the year. Okay, so location 1, 9120, the count which is given. To convert into ADT, I will multiply with the adjustment factor of Wednesday and March. So Wednesday adjustment factor is the same table. This one is bigger, 1.108, and March 1.1. Okay, so this will give me ADT for this. Okay, now VMT for 365 days. So this is per day. This one will be per day. Okay, so I multiply ADT by 365. So per day will be converted to the whole year. Then I will multiply with the length, which is 3 miles for location 1. Okay, so this will give me VMT for the whole year. So first I calculate the average for any day of the year, multiply by 365, it becomes whole year, multiply by the length, it becomes VMT. Okay, can you give me these values? Okay, so this is the VMT, right? For the second location, if I want, this is the location, the values are not matching, huh? So this is okay, I believe this one is ADT and then the 121 is the VMT, huh? Okay, so if I go for location 2, now I can do it directly. VMT 365, which is 10,255 multiplied by Tuesday September 1.121, September, which is 0.884, multiplied by 365 multiplied by the length 2.7. Okay, so yes, maybe location 2 this much, I don't remember, but you can see it how it is calculated. This is location 3. I just do one more for the record, okay, 060 multiplied by Friday August 1.015, August is 0.882 multiplied by the length, which is 2.5. Okay, and then multiply by 365. Okay, so you can see what these values are. Okay, the main thing was to tell you how it is calculated. These are the values. Okay, so they are for each locations, and I have already given you examples on how to calculate it. Does anyone have any questions? Okay. Moving on, now we are going towards studies which are called as specialized counting studies. In these studies, we are not focusing on the volume, we are focusing on the demand basically. So we are not focusing on the vehicles, we are trying to focus on the travelers, okay, or the demand for the area, not how many vehicles are going over the roads. Okay, so this is our main focus, but obviously to find out the demand is complicated. Okay, so we may still have to do something with the vehicles. Okay, so keep this thing in mind, but the idea is I'm trying to calculate the demand for on the basis of the area. Okay, we will discuss three types of specialized counting studies. All of them are based on calculating demand of the area. We discuss origin destination, cordon count, and screenline count. Okay, starting with origin destination. Origin means start, destination means end. Okay, so in these studies, we are focusing on the area of start of the trip and end of the trip. Area of start of the trip, end of the trip. How can I find out the start and end of the trip? We have three methods listed here. Okay, and I will tell you how we can do it in using modern methods as well. For we have license plate, we have postcard, we have interview studies. License plate means you have observers which are on the entry and exit points of the areas. They note down the license plate numbers as the cars are passing them. When the study is finished, they go to the office and they match the license plate number. So area 1 guy says, I saw this car going out from my area, and area 4 guy says, I saw the same car coming into my area. So now you know from which area the car started and which area the car went. Okay, so you know the origin and the destination. How we can modernize it? Instead of having observers, which will miss some of the cars obviously, you can have these new the cameras. Okay, the cameras which are for over speeding and for for running the red light and so on. They all of them are recording, or they have the ability to record your license plate. So instead of putting observers on the entry and exit points, you can put these cameras on the entry and exit point or something similar. So the license plate numbers will be recorded digitally, and you can later on compare it. Okay, compare the license plate numbers recorded by camera of exit area 1 with the entry of the other areas and so on and so forth. So that you can modernize in this way. Then we have postcard studies. What is the postcard? It's a small questionnaire with 3-4 questions only. And obviously we are looking for which question? From where you started your trip, where are you going? 2 main questions, right? And then you can add things like how are you going, what is your purpose, what is the time you will take, but we keep it short. Okay. Now in the old days, this was done using a small card on which these questions are written. You give the card, so on one side of the card you have the question, the other side you have the address. So you distribute these cards to the travelers in a parking lot, on a signal, on the bus stop, on the gas station. You distribute them, and the traveler, once they fill the card, they will send the card to the address you have given on the card itself. So you'll receive the card and you will get the responses from the travelers, and that response, there's no matching required. You know, the traveler has written, I came from this area, I'm going to this area. Okay. How you can modernize this? Instead of the cards, now you can use QR codes, right? You can use QR codes, and you give the QR code to the traveler. Okay. Or you can use some other survey method. Just when the traveler scans the code, or he goes to the link, it's already recorded that he is in this area and so on and so forth. Okay, so you can, instead of having a card filled manually, this can be done digitally. Okay, and then you have the interview studies. Interview studies are still done in the same old way, but interview studies are more detailed. So they have more questions than postcard, and that's why they are done usually in the form of home-based surveys. So you go to home, okay, house, okay. So they are usually done by the government organizations, and they conduct these type of studies annually. Okay, not for origin destination purpose, but origin destination is made a part of this type of survey. Okay, so origin destination included in the survey. Okay, you already know the house, where the house is, this becomes origin, and then you ask the traveler, okay, in your usual trip, work trip, study trip, which area you go. Okay, and the other things as well. So interview studies are normally organized by the government, and they are mixed, or they are combined with other data which the government needs. Okay, and they are house based. Okay, now, and the problem with all these surveys is it is impossible to cover the entire population, whichever method you are using. So these methods just give you a sample of the actual data. They just give you the sample. Okay, so how do I convert this sample into the more accurate number I'm looking for? So we prepare an origin destination matrix. We support this matrix with some field count, and then we try to adjust the matrix, calibrate the matrix to give us a more accurate count of area to area movement. Okay, so the origin destination count is a sample. I need to have a more detailed count for area to area movement. So for that, I prepare origin destination table, which you see here in the slide, and this is coming from the sample. Then using that, and field count, I try to adjust this sample into the actual real number which I should have for area to area. Now what field count, so if you look at the matrix, this table, okay, these are the area numbers, only 4. The actual survey may have many more areas, 10, 20, 30. Okay, so you will see the same number of rows and columns there. But in this one, for the sake of explanation, we have only 4. And obviously there are softwares which can do this for you, like the calibration, the calculations which I'm about to tell you. But for the sake of class, we are keeping it simple so you can understand. So we have 4 areas. Okay, these 4 areas could be origin for some people and destination for some other people. Okay, so the numbers which you took from this sample are here. Okay, so 50 people said their origin and destination both are area 1. People who are living in heaven, huh? They don't go anywhere. They just come out, and they have the university next road, and they have the cold store on the other street, and they have the mosque in front of their house, and a school on the roof of their house, and so on and so forth. Okay, so these people don't travel too much. Then we have 8 people who are saying we go from area 2 to area 1, and so on and so forth. So if you look at the diagonal counts, these are intra area counts, people who are just roaming around within the same area. Okay, if I add the counts column wise, I get the full or the total from the sample for this area which have their origin, which are coming out from this area. Okay, so 88 from my sample are coming out of area 1, 99 are coming out from area 2, 97 are coming from area 3, they are coming out. And if I do the total row wise, I'll get the count which is entering this area from my sample. Okay, so all of these people are entering area 1, so the total is 95. For area 2 the total is 106. So this is for the sample. Okay, the first 5 rows and columns are for the sample. Then you see an extra column here, an extra row here. So these are from the field counts. The field count is just taking total vehicles entered, total vehicles exit, vehicles or people, total for each area. So, and obviously it should be in the same time period. So for area 1, they recorded on the field that 250 people entered area 1 total. Okay, now the total I am getting for the sample and the total I have in the field, you can see they are completely different. For area 2 again, and the same thing for exit as well. So from area 4, they recorded 400 people were exiting from area 4, and the sample only gave me 24. So there's a lot of difference. Okay, so how do I combine these numbers? So how do I make these numbers same? So because the sample should reflect the actual, right? So I have to make them same. So we call it calibration of the origin destination matrix. So the table of the sample is called OD matrix, origin destination matrix. So I need to adjust the origin destination matrix. For adjusting it, I will calculate the ratio of the last 2 columns and the last 2 rows. Okay, and these will become my adjustment factors. Okay, I'm talking about these factors. Okay, so I'm doing this upon this, 250 upon 95, 2.60, 210 upon 88, 2.39. Okay, and the same for every row and column, taking the 2 last, taking the ratio, and I'm getting this. So I'm doing the volume, field volume upon the sample, field volume upon the sample of total of the sample. Okay, now what do I do with these adjustment factors? I'll do this. Okay, so I refers to the column and J refers to the row. Okay, so every number here is in the ith column and the jth row. Okay, so for 50, I is 1 and J is also 1. For 10, I is 1 and the J is 2. Okay, and you have the factor for each row and the column. Okay, so I will take 50 for example. I believe I have done it here. Yes, so 50 multiplied by the factor of the column in which 50 was and the row in which 50 was. Okay, so 50 was in this column and in this row, so multiply 50 with the average of this and this, which we are doing here. So this gives you 125. Okay, so it was 50, I did this with 50 and I got 125, so this becomes 125. Okay, and so on and so forth for all the numbers. So this was actually, this one was actually 10, so 10 will be multiplied by the average of, now 10 is in this column 2.39 and this row 2.92. Okay, so when I do this I get 27. Okay, so this is how these numbers are changed. So these were the initial numbers and this is after multiplying with the average of the factors. Okay, when you change these numbers, obviously the total of each row and column will change. Okay, and then you can recalculate the factors like they have done here. Okay, so again I'm doing volume. Volume will not change because this is field observation. I did not touch the volume. I did not touch this row or this column. It is as it is. So I will recalculate the factors. Okay, 210 upon 232.9, 200 upon 251.8, and so on and so forth. Okay, is this done? Okay, that depends upon what factors you are getting. Okay, if all the factors, remember, all the factors are in this range. If all the factors are in this range, all the factors meaning all the columns and all the rows. Sorry, it is hidden here, but all these factors, so 250 upon 267, 310 upon 222, all of these should be in this range, and all of these should also be in this range. Okay, now this is not shown here, but if you see this one is not in my range, this one is not in my range. Okay, so that means I need another trial. Okay, that means I need another trial. So I need to further adjust or recalibrate this matrix in the same manner. Okay, but now the factors will be the new ones. So, and the value will be the new one as well. So now I will adjust 125 by multiplying with the average of 0.9 and the ratio of these two. Okay, so for I believe it is done here, not done. Okay, so I will take 125 for example, multiply, use the bigger bracket here, 0.9, which is for the column. Okay, for the row it is 250 upon 267, whatever it is. Okay, divided. Okay, so this one gives me 116 now. Okay, now you can see the and this will be done with this entire matrix. The same will be done with this entire matrix. So all these numbers will change. Again, I will not touch the volume. The volumes are still the same. Okay, but these numbers are changed, so the total will change. When the total changes, the factors can be recalculated. So these are the recalculated factors. So you can see I had 0.9 here, now it is 0.97. I had 0.8 here, now it is 0.87. Well, it was 1.06, now 1.04. It was 1.16, now it is 1.06. Okay, now should I stop here or not? And these are the factors for the rows. Okay, should I stop my calculation or should I move on? Should I say this is my final matrix, or do I need more iterations? Yeah, we need more because we can see, for example, this which is 0.87 is still out of the range. My range was 0.9 to 1.1, so this one is still out of the range. I need more iteration. This is that final iteration, and you can see the final factors, all of them are in the range. Okay, now this is repetitive calculation. So there is a check when you recalculate the factors. Every time you recalculate the factors, they should be getting closer to 1. All the factors should be getting closer to 1, even if they are not coming in the range. So for example, the first trial, you look at the columns here. So it was all 2, 2, 3, 4. Okay, now you can see all of them are much lower, much closer to 1. Okay, but they are still factors out of the range. If I look at the second iteration, okay, these are getting much closer to 1, 0.9 to 0.97, 0.8 to 0.87, 0.6 to 0.4, 1.6 to 0.6, and so on and so forth. So all of them are getting closer to 1. Okay, even if it's still out of the range, 0.87 is still out of the range, but it was more out of the range here. It was 0.8. Now it is actually getting closer to the range. So every iteration, the factors, all the factors, not just 1 or 2, all the factors will be getting closer to 1. Okay, will be getting more and more in the range. Okay, So this is your check. So when you do one iteration, compare the factors with the previous ones. All the factors should be closer to 1 now. Okay. Then we have the next one. Next specialized counting study is a cordon count. Cordon means boundary. Cordon means a boundary. So you select an area which is of high importance for you. High importance in terms of traffic. Okay, high importance in terms of traffic. So in terms of traffic, this area is very important. Okay, and around this area you select a boundary. You make a boundary. Okay, like on the map, and then you see how many people are crossing this boundary. Crossing boundary means what? They are entering and exiting the area, right? They are entering and exiting the area. So this is what you do in cordon count. Now usually the areas which are selected for cordon count are commercial areas, because commercial areas, they generate lot of traffic. Okay, so usually these are the areas, but I will tell you another example which we did for Bahrain. Okay, and when we went to the ministry, they were also considering this particular area to be very important, but usually it is done for commercial areas. Okay, what is the purpose of cordon count? We want to know in each in the within the area at any particular time how many vehicles are accumulated. If you go to, for example, Manama Souk or Muharrak Souk area, you will find that they don't have individual parkings for each shop and so on and so forth. There is a area parking. Okay, so and you have to manage the traffic in the entire area. Okay, so this is how the areas which have high traffic demand, this is how we manage them. We manage them at the area level. Okay, so this area can have this much parking in total, and you have to walk. You will go in the parking area, then you have to walk. Okay, so we are saying that traffic is so high that managing each facility separately is not possible. So we'll manage it on the area level. So then we need to know how many vehicles we should expect at the area level. Okay, so this is the thing. Yeah, then as I mentioned, you select the area. Now the area doesn't have a physical boundary. It's not like a wall we are building around the area. Okay, it's just you are marking a line, and whoever crosses this line, you say, okay, it has crossed the cordon. Okay, so how do I make this line in my area? So there are some points given here. The important thing is in making these lines, you try to take advantage of any natural feature. Okay, so for example, around an area you have a mountain range or a river. Okay, so this becomes a natural boundary. Okay, so if you go, for example, Sitra, so you know on one side of Sitra you have the sea. Okay, so if Sitra is my cordon area, then sea becomes my natural boundary. Yes, the boundary is not in the full area, so the sea is not totally surrounding Sitra. We have some land connections there, but wherever possible I will make the sea as part of my boundary. Okay, so and I already gave you other examples as well. It could be a mountain range, it could be a railway line, it could be a river, anything which is dividing this area from the rest of the city, that should be your cordon should be along that line. Okay, naturally. Another thing which you have to keep in mind is the size of the area which you are selecting. Okay, if you select an area which is too big, then there is possibility that in one area you will have lots of land uses. Okay, now as I told you, we are doing this so that we can plan for the entire area. You cannot plan for an entire area which has multiple land uses. Becomes complex, becomes very complicated. Okay, so while we are selecting the size of the area, we try to focus on one land use. Okay, so that planning becomes easier, because you know, in if the area is only commercial, so I know the reason for people coming in and going out, which is only one activity, which is commercial. Okay, same thing for education and so on and so forth. But if it is mixed, then okay, I have peak hour now. Is it because of commercial activity? Is it because of schools or what? So this is why we try to manage the land use. Now, what about the minimum size? Sometimes in an area, one particular facility can be dominant. For example, if you go to uh, which area? And let's say you go to Seaf area. Okay, in Seaf area, your biggest attraction could be, the biggest attraction could be city center. Now, somebody may say, since most of the traffic is coming because of city center, let me make my boundary around city center only. Okay, now this is too small now. Okay, this is too small. You are missing the other facilities that can combinedly generate a lot of traffic. So maybe city center is generating 40% of traffic. Okay, so it is important than others, but that doesn't mean others are not important at all. Okay, so first thing was use the features which are already dividing the area as boundary. First thing. Second thing was the size. In the size, you try to keep single land use within your boundary, and you try to make sure that you do not focus on one particular building or one particular facility. Rather, you try to cover as many as possible for the same land use. Okay, so these are some of the things you need to keep in your mind. Okay, this is example of a cordon count. Okay, the hours are written here. Now you see the first count, which is from 4 to 5 a.m. Now this is initial count, which is done before the start of the activity. Okay, before the start of the activity in that area. So we are not expecting too much traffic crossing the cordon. Okay, so in the first time period, we are not expecting too much traffic in the passing the cordon or crossing the cordon. Okay, so you can see 0 0 here, vehicles entering, vehicles leaving, 0 0. Okay, so what are these 250 vehicles? These are vehicles already present in the area. Okay, usually vehicles which are parked on the side of the streets. Okay, on the sides of the streets, and they could be just any vehicles which are just moving around or something. Okay, but they are within the area, so you take a count within the area. Okay, and you take it at a time where you know that the outside count will be almost none. There could be maybe 1 or 2 vehicles entering or leaving, but we know that would be very, very low, so we can ignore it. Okay, it will not create too much error. Okay, so once you have done that, then for the next hour, you start counting vehicles entering and leaving as well. You only count vehicles entering and leaving only now. Okay, so 250 were already in the area when you started. 100 entered, so total is 250 plus 100, but 20 of them left in the same hour. Okay, so the total which are remaining in the area is 330. 250 already there, 100 entered, 20 left, so 330 as the vehicles which are in the area at 6 a.m. and the same thing for the next hour. 330 already there, 150 entered and 40 left, so 440 vehicles remaining in the area. Okay, so this is what we call the accumulation, and now it tells me that the vehicles go up to 1180 and they go around this point around noon. So the maximum number of vehicles I can expect in the area is this much, and at what time should I expect this? At this time. Okay, so I want to start a new service, I want to manage parking, this is a critical time. Okay, in some cases you may want to divide your vehicles into different types, which you can see in this graph. Okay, the total is divided into cars and trucks. So they are keeping a separate count for cars and separate one for trucks. This is again a very important feature of commercial area where trucks can be causing a lot of problem because they are bringing goods and so on, and they need more space. They need a special parking and so on. So you may have a special count for them, a separate count for them. Okay. This is the study which we are doing, and as you can see, we did it for the diplomatic area, which is not a commercial area, it's an office area. Okay, so you have embassies there, and you have some very important offices there. Okay, I believe some of the offices are now shifted, especially those belonging to the government. So what it was done in 2018. Okay, and you can see the same thing. Okay, before 8, they started before 8. Okay, and they did the accumulation only. Then 48 plus 409 entered, 427 left, and this is accumulation and so on and so forth. Okay, so this is it. Once you have the cordon count, you can make it more detailed by focusing on the points from which the vehicles are crossing. So this diagram focuses on the points of crossing for the traffic. So not only the total, it also tells you from which side the vehicles are coming and going. Okay, so how many are coming from this road, how many are coming and going from this road, how many are going out from this street, and so on. So you can make it as detailed as possible. Okay, so you have seen the separation for different types of vehicles, and you can see the separation for different crossing points. So a dashed line is basically your cordon. Okay, and they made it into a square here. Okay, another thing which I forgot to mention, you make sure that your boundary is crossing the roads. If it is crossing the road, if the boundary is crossing the road, it should cross at the mid blocks, not at the intersections. Okay, so you can see all of them are crossing at the mid blocks. Okay, none of them. So this is an intersection. So we didn't cross our boundary over here. We crossed it over here. So there is no intersection here. Okay, because at intersections vehicles turn. So if I try to take the count at the intersections, I will need more people because of the turnings. Okay, but if I just take it at the mid blocks, my counting effort will be less. Okay, so I'm only counting vehicles going and coming. That's it. No turning, U-turn, left turn, right turn. Okay, so that's why we keep it on the mid blocks. Okay, so now we have 3 things which you need to keep in mind for the cordon. First of all, use the natural boundary. Secondly, make sure the area size is enough to cover the land use. And thirdly, crossing at the mid blocks. Then the third one we have is screen line count. A screen line is also a sort of a boundary, but not around an area. It is between 2 areas. Okay, so the difference between cordon and a screen line, both of them refer to boundaries. But when we say cordon, we mean boundary around the area. When we say screen line, we mean boundary between 2 areas. Okay, so so between 2 areas means we have 2 areas, right? Cordon we had only 1. So a screen line becomes a mini OD study, mini origin destination study. Okay, because origin destination, I told you in our example we had 4 areas, and if you are doing it for the entire city, you may have 20, 30, 50 areas. But in screen line we only have 2 areas. Okay, so if you are doing origin destination for 2 areas only, we call it screen line count. And we have the same guidelines. Screen line is a line which you will make on your map. Okay, it's not an actual line. So again, you need to keep in mind the same guidelines which I mentioned for the cordon count. If there is a natural feature between the 2 areas, that feature becomes your screen line naturally, obviously. And the screen line should cross the road. If it is crossing the road, You should cross the road at the mid block, not at the intersection. Okay, the same two guidelines we had for the cordon count. Here we are not discussing the size because we are not talking about one area. So the other two guidelines, crossing at the mid blocks and making a natural boundary as part of the screen line, applies here as well. You can see we have two areas here, and between the two areas we have a river. Just imagine, no? You have a river. So it happens in areas like Amsterdam, and there's a city, I believe it's Venice in Italy. So these have these cities have rivers in between their districts of the same city. So here they can make the river as the screen line. Okay, and then you can have others as well. Okay, you can have a mountain range. You can even have a highway. Okay, between the two areas. Okay, but whatever you have, you feel that this is the line which looks between the two areas, you can make it as your screen line. And then if you have to cross it from a road, then you cross it from the mid block, not at the intersection. You can move it a little bit forward or backward just to make sure it it crosses from the mid blocks. Okay, now in screen line count, the procedure is same which we discussed for origin destination. Okay, you take the count, you make the simple small 2 by 2 OD matrix, you take the field count and you adjust and so on and so forth, so it will be easier. But in a screen line count, usually in OD matrix we cover the entire city. So the trips which are not from my zones are very few, they are negligible, because I already covered the entire city. But in screen line count, I'm only covering two districts or two areas. So there will be a lot of trips which are not from these two areas, but they are still crossing. So let's say I'm doing it between Manama and Muharrak, and there could be a guy who is coming from Hid, and he is crossing Muharrak and he will go somewhere else. Okay, so this guy is just crossing. Okay, so he may show up in my count, but he is not from these two areas, Manama and Muharrak. Okay, so these trips are called as external crossings. So what are external crossings? The people who do not belong to the areas which are divided by the screen line count. Okay, so they belong to some other area, they are just crossing. Okay, so we call them external crossings. And then we have the internal crossings, the crossings which we want, and then we have the total, which is called as gross crossing. Gross is internal plus external. Now if you have selected your screen line properly, if you have selected your areas properly, then external crossing should be very low compared to internal crossings. Okay, because if your internal is lower or internal and external are very similar, that means you don't have a problem because of your areas. The traffic is coming from somewhere else and you are missing that area. Okay, so it's very important that the areas which you select for these studies are actually important areas for traffic. Okay, so one way of knowing it that the area is important for traffic is comparing external and internal crossings. Okay, now we can have a screen line count, let's say between Khobar Dammam, Saudi and Bahrain. Okay, so if I'm doing a screen line count between Khobar Dammam and Bahrain, so these are my two areas. First area Khobar Dammam, Saudi. Second area Bahrain itself. Now there's a natural screen line between them. Which natural screen line we have between these two areas, Khobar Dammam and Bahrain? What is my natural screen line? Yes, what natural screen line we have if I am doing the screen line count between these two areas? Like I don't have to make anything. Like if I look at the map, I will see it, that this is the thing which is dividing these two areas. What is that? the C. Okay, the C becomes a screen line. Okay, and the screen line is crossed by the causeway. So if I need a count between these two areas, I will just count people crossing the causeway. Okay, I heard they were trying to make another causeway, and but I don't know. Okay, but you get the point. Okay, so this okay, then you have some so this is the end of this topic, and you have some examples which you should look for. Okay, it will help you for practice. And then okay, now this is a very important topic for your term projects. Okay, the last thing which you should know to finish your projects. Okay, so this is from chapter 7 and 28 of the textbook. This is the outcome of the course we are trying to cover in these topics. Okay, how to calculate the level of service and capacity. We are only doing it in this topic for uninterrupted flow facilities. Okay, uninterrupted flow facilities are those which do not have interruptions. What are interruptions? Any of these things. Okay, now if a highway has a 2-mile part which is without these interruptions, then we consider it as uninterrupted segment. Okay, so maybe a highway has a signal, but from that signal up to 4 or 5 miles there is no other interruption. So that part of 4 or 5 miles becomes uninterrupted. Okay, so uninterrupted could be the whole highway, or it could be just a part of the highway if a highway has interruptions. But that part of the highway should not be less than 2 miles. Okay, the interruption appears before 2 miles, the whole highway is considered, or the whole segment is considered interrupted. Here we are going to talk about 3 types of highways. All 3 of them have uninterrupted segments. First one is freeway. Freeway is full uninterrupted highway. Full uninterrupted highway. So they don't have any intersections. Okay. Obviously then if you are talking about a highway which does not have interruptions, then the speed will be very high. You need a median. You cannot have one lane. You need more lanes because traffic will be higher as well. People want to go out from the high speed road, right? So traffic will be higher. You need a median for safety. You need to keep high speed, and you need more lanes. So this is a freeway. No interruptions. You need a median. You need more lanes. Then we have multi-lane highway. This highway has uninterrupted segments. So it is not full uninterrupted. It has parts which are uninterrupted. So the parts which have 2 miles, more than 2 miles, which are uninterrupted. So these highways, multi-lane means what? They have multiple lanes. Okay, so they have multiple lanes. So multiple lane meaning each direction has multiple lanes. Each direction has multiple lanes. The other things, median, speed, they are variable. Speed can be high and low, but it's lower than the freeways. Speed on the multi-lane highways usually lower than the freeways. Median, maybe there, may not be there. Okay, because the speed is lower, so median is not a necessary part. Then we have 2-lane highways. 2-lane are rural 2-lane. Rural 2-lane. Okay, so in rural areas traffic is very low, so we don't need multi-lane highways. Okay, because of low traffic, and because we have low traffic, we don't need intersections as well. Okay, so in the rural area, we don't need that many intersections as well. So then 2-lane highways can be with median, without median, but the main thing is they are uninterrupted, so they have at least 2 miles or more without interruption. They may have a median or may not have a median, and they have 2 lanes. So the fixed things are they have 2 lanes, and they are in the rural areas, and so on and so forth. Okay, for all these highways, we have a manual to calculate their capacity and level of service. That manual is called as Highway Capacity Manual. This manual is published by TRB, Transportation Research Board. It's a academic board. They do research and they publish things, books and conferences and so on. and they work under National Academy of Engineering. Okay, so the people who are doing the research are TRB, and the people there on top of them is National Academy of Engineering. They published their first manual in 1965. Then you can see the years. The last one was published in 2022. I heard that the next one will be published in 2028. Okay, you want to study with the latest manual, you can just stay here for 2 more years, and maybe we will study from 2028 manual. Uh, the first software which was developed for these calculations was by a university in Florida, and this was to perform the calculations given in the manual. But now any traffic simulation software you pick, for example Vism or Synchro or Sidra, whatever, any traffic simulation software, and their latest version will have or can help you with the calculations for capacity and level of service. So this has become very common now, but earlier it was a specialized software. Okay, this software is for this. Okay, we already know the definitions of capacity. Okay, what is the definition of capacity? Tell me, what do we mean by capacity? Capacity of the road. Okay, so how do you define capacity of a road? We are reading now. Okay, so this is very similar to what the manual is saying. So this is the full definition of capacity according to highway capacity manual. The basic concept is same: maximum flow rate. Okay, the maximum flow rate which can go from the highway. Okay, but the manual covers highways and other facilities as well. So you can see in their definition they are using persons and vehicles both. Okay, persons and vehicles. So vehicles is for highways and person is for other facilities which are covered by the manual. And according to the manual, they are saying that capacity is not something which you can fix. Capacity is an estimate, and the actual maximum flow rate on the vehicle of the highway can be slightly more or less than the value you are using as an estimate. Okay, so for example, you may say that we have 2000 vehicles which can pass from this highway. Maximum flow rate is 2000, but you may have a day on which it is raining. So on that particular day the highway may not be able to serve 2000 vehicles because people are going slowly. Okay, and so on and so forth. So capacity is an estimate. Second thing they are saying is when you calculate capacity for a point, until and unless you change the characteristics of the road, the capacity will remain the same. So I calculate capacity at point A. Okay, so if the characteristics of point A are the same as point B, then the capacity is also same. So the section between two points which have the same characteristics throughout, they call it uniform section. So a uniform section has the same characteristics from start to end. Okay, so for that the capacity should remain the same. What changes the capacity? It's mentioned here. A road design can change the capacity. Very obvious. 2 lanes, less capacity; 3 lanes, more capacity. Less width, less capacity; more width, more capacity. Environmental conditions. I already gave you the example of rain. If the environmental conditions are good, capacity will be higher. Environmental conditions are bad, capacity will be lower. Traffic conditions. Traffic conditions including mix of vehicles. What type of vehicles are passing through the highway and what proportions? So a highway which has higher proportion of trucks may have lower capacity because trucks take more space and they go slower, and vice versa. And control conditions. Okay, control condition mean what you are doing on the intersections to control the traffic. Okay, so signals, roundabouts, okay, they all have different capacities. So as I mentioned, we are covering uninterrupted, but the definition is for all types of highways. So that's why control conditions are also there. Okay, but if we are talking about uninterrupted, then control conditions, we will not discuss control conditions. Okay, this table provides you capacity under ideal conditions for different types of highways. So we have three types of highways. Okay, freeways, multi-lane highways, and two-lane highways. And we have the capacity for each one of them under ideal conditions. What we mean by ideal conditions, we'll discuss later on. But you can see for freeways and multi-lane highways, the first two columns, the capacity changes as per the free flow speed. Okay. Now who can define free flow speed for me? What is free flow speed? Yes. How do we define free flow speed? Anyone? Okay, good. So yes, when traffic volume is very low, so drivers are moving freely. So at this, in this conditions, the conditions which you mentioned, okay, these two conditions, both of you have mentioned, your speed is basically the speed according to the road, according to the design of the road. Okay, so you are not constrained by control devices, you are not constrained by other people. So you know, you are basically just going along the road as per the you know, as per the design of the road. So free flow speed, the point is free flow speed is indicator of the design of the road. Okay, and later on you will see how design of the road affects free flow speed. Basically it's an indicator of the design of the road. Okay, so free flow speed decreases, that means design of the road is getting narrow and having less flow in terms of capacity. Now all these values which you see in this table are in passenger cars per hour. PC means passenger cars. If you look at two-lane highway, capacity is fixed. Capacity for the full road, both lanes, 3200 per hour, both lanes, and one of them will have one direction will have 1700. Okay, now if one direction can have some 1700, the other one added, okay, both of them are one lane, right? So one lane 1700, the other lane, if I add 1700, I will get 3400. Okay, but here the total is given as 3200. Now what's the reason why I am not just multiplying the capacity of one lane by 2 to get the total? Because on two-lane highways the lanes are very close to each other, so filling up one lane affects the other lane. So when one lane can go up to 1700, it will start affecting the other lane. So this 1700 will not let the other lane go up to the same number. Okay, so this is why. Okay, so on two-lane highways both lanes cannot go up to the same level, and this is what they have estimated in their studies. Okay, So but this is just an estimate. Okay, later on we will see how to get the actual number. Now we know about capacity, we know about free flow, we know about traffic jam. Okay, so we already know about three different traffic conditions. One is called as capacity, the maximum flow rate. The other one is called as free flow, where traffic is very low. And the third one is called traffic jam. Now traffic jam we know is a bad condition. Okay, we don't want to have traffic jam. Then we also know that capacity, okay, even if you don't know, we know capacity is very unstable condition. Okay, the capacity means you are just at the edge of traffic jam, you are very close to traffic jam. So if anything happens, you will start traffic jam directly. So you don't have any cushion, you don't have any factor of safety. Okay, so we don't want to have you don't want to go near capacity as well. So you don't want to have traffic jam, you don't want to go near capacity, or you don't want to be at capacity, and you don't want free flow as well. Why? Because free flow means the highway is underused, traffic is very low. Okay, so traffic jam means you are in bad condition. Near capacity or capacity means you are in very unstable condition, you can go through traffic jam anytime. And if you go at free if you're targeting free flow, that means you are underutilizing your highway. The highway doesn't have much traffic, so why was it built if it doesn't have much traffic? So this discussion of different traffic conditions shows that just having a number for capacity, that this is my final value, is not enough for traffic. Okay, there are different stages of traffic and each one of them shows something different. Okay, traffic jam shows something different. Capacity is a number, but it can mean something which is unstable. And free flow again is a number, but it can mean that you are underutilizing. And then there can be things in between them as well, things which are between free flow and the other levels. Okay, so we need to understand different levels of traffic, different conditions of traffic. Okay, having a number for the extreme condition, which is the capacity, is not enough, or just focusing on free flow is not enough. Okay, so we need to understand different conditions of traffic. That's why they came up with the concept of level of service. Okay, so what is level of service? It is dividing traffic flow conditions into different levels, including the extreme levels as well as something which is between them. Okay, so level of service concept was given in the highway capacity manual of 1965. It is their patent. Everybody is using it, but this was started from there. Okay, even when I was studying, we didn't have the full concept of level of service, because even in Pakistan we were using British and Indian codes and standards. So okay, so there could be still countries which are officially not using level of service, or they are not putting it in the codes, but they are still using it. Okay, so going back to the point, this concept was given by them. What is level of service? It's a quantitative leveling, quantitative categorization, quantitative classification of the performance or quality of the traffic. Okay, so we have different levels. Okay, and these levels are divided very conveniently for you to remember from A to F. The thing which you feel very very easier to remind you of, to go from A to F. And you know that A is always good and F is nobody wants F, right? So this is the scale which they come up with, and this is some explanation of these level of service concepts. Okay, so like I said, it goes from A to F. A is the best one, obviously. Then it means free flow condition. Well, as you mentioned, you are not influenced by other drivers. The lanes are normally empty. You have lots of space between you and the other driver, so small blockages will not create any problem for you. If you have a small blockage, you can continue without any problem. You can easily go into the other lane without stopping in your lane. Okay, the spacing between you and the other car could be as long as more than 400 feet, okay, or almost 500 feet. The level of service B, it is still considered as free flow, so your speed is still very high, but your spacing is less. So you are not reducing your speed, but you can feel the other car is closer to me. So you are more vigilant, you are more careful, but you are careful at high speed. Okay, so you still have gaps available for you to absorb any traffic disruption. There's a traffic disruption, there are lots of gaps available. You can still maneuver around the other car and continue on your own way. Then you have level of service C. Spacing is getting reduced, but you are still maintaining your speed. But now the gaps are less. So if there's a blockage, you may have to be more vigilant, and you may have to wait for your turn to go to the other lane. Okay, so any maneuver to the other lane will reduce your speed. But if you are just focusing on and going straight, then you can go do it at very high speed. So you can see the A was almost 500 feet spacing. This one is only 200 feet. It's getting less and less. D is where the reduction in speed starts to happen. Okay, so now you are not, the reduction in spacing is also reducing your speed as well. So reduction in spacing means increase in density. Now it is directly impacting your speed, it's getting less. And if there's a breakdown here, the gaps are not enough to continue without any stoppage. So any breakdown will definitely require you to stop. And even within your own lane, you are going at a low spacing, you need to have more control, okay, more vigilance. Then your level of service E, which is defined as capacity. So you are almost at the maximum flow you can have, okay, but this is complete saturation. So this is not stable, as I told you. Okay, somebody is going and he's looking at the map and he slows down for a couple of seconds because he wants to decide whether to change the lane or not. Even this will create a queue. Okay, we cannot let any driver even slow down than the rest of the drivers. There is not enough spacing for that as well. And if that driver decides I want to change my lane, he will definitely stop traffic in both the lanes. Okay, so there is no gap to continue from for even these minor actions. Okay, so this is complete capacity now, full, you are at the full capacity now. And then F is anything beyond capacity. So this is breakdown condition, and you have a long queue, and you may see it you may see it at particular peak hours. Okay, so you are going at very low speed, you are stopping and going, you cannot go continuously, and so on and so forth. Okay, it can happen at near ramps, and we have discussed it earlier, the breakdown conditions. Okay, we call it the breakdown conditions. Okay, so I will stop here.